In this video, you'll learn everything that you need to know about object pooling, which is a way to dramatically increase a game's performance with just a couple simple lines of code. We're the Blackthorn Brothers. If our videos are helpful to you, make sure to like and subscribe. And with that said, let's get started. But just before that, guys, we've got a really exciting announcement to make. Liam and I have created a free game development course. It will teach you the fundamentals of Unity and C# while actually building your very first game. So it's a must-have crash course if you're interested in this incredible art form. The link is in the description. Again, it's completely free. Okay, back to the tutorial. For this video, we'll be working with this very simple scene. We just got this little dragon character that can fly around and shoot small projectiles and also larger ones using the left and right mouse buttons. At the moment, we're spawning in these projectiles using the instantiate function. And then when the projectiles collide with a wall, we are removing them using the destroy function. The problem is that the instantiate and destroy functions can be quite taxing. It's of course completely fine if you're just using them a little bit, but if you have to spawn and destroy a very large amount of objects, then it can start to compromise the game's performance. That's where object pooling comes into play. Instead of instantiating a new projectile each time, we'll instead instantiate a bunch of projectiles once at the very start of the game and disable them all, so hide them, and then simply enable one, so reveal it, whenever we need to spawn in a projectile. And instead of destroying a projectile when it hits a wall, we'll instead simply disable it, so hide it in our game. So the principle is very simple. Instead of using the instantiate and destroy functions, which can be very taxing, we instead instantiate a pool of objects, so a bunch of objects once at the start of the game, and then simply enable and disable those objects where we need to, which is way more performance. We're basically recycling game objects. So let's add object pooling to this game. I'm going to go to my scripts folder and create a brand new C# script that I will call object pooling. We're going to make it so that this script can handle multiple pools for all the different type of game objects that we might want to spawn in our game. In our example, we've got the small projectile and the larger one. We're going to start by creating a private dictionary. This dictionary is going to store all of our object pools. A dictionary is a type of collection similar to a list, but it stores key value pairs. This will let us tag each object pool in our dictionary with a key, making it easy to retrieve the correct pool when needed. That's why it's called a dictionary. A dictionary has a bunch of words and definitions. The words are the keys and the definitions are the values. Our dictionary will use game objects as the key type since it represents the prefab for each object, and the values will be the corresponding object pools for those prefabs. Each object pool will use a queue of game objects, which is similar to a list but more efficient than an array. We'll call this dictionary pools and we'll initialize it to a new dictionary of game objects and game object queues. Then let's come down and create a function to create a pool. So I'll make a private void function called createPool, and it'll take in as a parameter a game object for the prefab that we want to spawn, and also a int for the amount of prefabs that we want to spawn that I'll call pool size. So remember that creating a pool simply means instantiating a bunch of prefabs at the start of the game, storing them in a object pool queue, and then disabling them. So let's do just that. I'll create a game object queue called newPool and set it equal to a new game object queue. Then we'll create a for loop and we will continue to loop as long as I is smaller than our pool size number. Inside of this loop, we'll simply instantiate our prefab and store it inside of a game object variable called obj, which is short for objects. We will also parent the spawned object to the object that will have this script attached to it to keep our hierarchy clean. Then we'll deactivate the object by saying obj.set to false. And finally, we'll add it to the new pool queue by saying newPool.enqueue and passing in our object that we just spawned. Okay, once we're done with the loop, we'll simply set our pool's dictionary of key prefab to be equal to our new pool. So now this new pool will be linked to the specific prefab. Okay, let's test this out. I'm going to create a public game object variable called small projectile prefab and also a public game object variable for the large projectile prefab. Then I'll make the start function and we'll call our createPool function and I'll pass in small projectile prefab and I'll also set the pool size to 20. And let's also call the createPool function, but this time for large projectile prefab. Save the script and go back to Unity. Let's create a new empty game object that I'll call object pooling, and let's attach our object pooling script to it. I will drag and drop these small projectile and large projectile prefabs into the respective slots. If we now press play, you'll see that under the object pooling game object, you'll find 20 instances of the small projectile and 20 instances of the large projectile, and they are all deactivated. That's exactly what we wanted. But at the moment, if we start shooting, you'll see that we are of course still instantiating new projectiles. So we'll now see how to use our object pools to avoid having to use the instantiate and destroy functions. So back in my script, I'm going to create a public void function called activate objects. And it'll take in as a parameter a game object called prefab, so that our function knows what prefab pool it should grab an object from. It will also take in a vector3 for the position at which we want to activate it at, and also a quaternion for the rotation at which we want to activate it at. The first thing we want to do is retrieve the correct pool from our dictionary. So I'll make a queue of game objects variable called pool, and it will be equal to our pools dictionary with the key prefab, and that will fetch the pool for that prefab. Now that we have the correct pool, we'll check with an if statement if there is still an object in the pool. So if pool.count is greater than 0. If that's the case, then we want to remove the first object from the pool by saying pool.dequeue, and we'll store that object in a game object variable called obj for short. Then we want to activate the object by saying obj.setActiveTrue. We'll then set the position of the object with obj.transform.position and setting it equal to the position parameter, and rotation with obj.transform.rotation and setting it equal to the rotation parameter. So now let's make the public void function called remove objects that will take in as a parameter a game object called obj. We'll simply deactivate the object by saying obj.setActiveFalse. And then we want to add obj back to the pool. But we need a way to know what prefab this object that we are passing in this function comes from, so we can add it back to the correct pool. To do so, we're going to create a brand new script called prefab identifier. We'll attach this newly created script to both of our projectiles. Inside of the script, I'll simply create a public game object variable called prefab, and we'll add the hide in inspector tag to hide it from the inspector. Then let's make a public void function called setPrefab that will take in as a parameter a game object called _prefab. Inside, we'll just set prefab to be equal to _prefab. Now in the object pooling script, when we create our pool and instantiate an object, we'll fetch the prefab identifier script on it and call setPrefab, and we'll pass in the prefab param. So we've done all that to make sure that each instance of our objects knows exactly from what prefab they come from. So now back to our remove object function, I'll say pools of key obj.getComponent prefab identifier .prefab.enqueue obj. And we are now sure that we are adding the object back to the correct pool. And there we go. Let's now finally modify a little bit our player and projectile scripts to use our activate object and remove object functions, and we'll be all done. So inside of the player script, let's first of all get a reference to our object pooling scripts. So I'll make a private object pooling variable called object pooling, and inside of the await function, we'll set it equal to find first objects by type object pooling. Now that we have a reference to the script, inside of the shoot function, instead of instantiating a new projectile, we will say object pooling.activate object, and here I'll pass in the small projectile prefab, shotpoint.position, and shotpoint.rotation. Let's do the exact same, but this time for the large projectile here. In the projectile script, we'll also get a reference to the object pooling scripts. And once we have that, we'll come down here to the place where we are destroying the projectile. Instead of using the destroy line of code, we'll say object pooling.remove object, and we'll pass in game object, which just refers to this game object that has this script attached to it. Okay, and there we go. Make sure to save your script and head over back to Unity. If we now press play, you'll see that we're no longer spawning and destroying our projectiles, but instead they're getting activated and deactivated, which is way more performance. Okay, that marks the end of this tutorial. I hope you enjoyed it and learned something. If you did, don't forget to hit like and subscribe. It means the world to us. Stay tuned for new tutorials every single Sunday, and don't forget to check out our completely free course to starting game development, link in the description. Cheers.